Welcome to the toughest job site on Earth. Sparks fly, steel roars, and machines crush like beasts. Get ready for raw power, epic dust storms, and unstoppable action. This is heavy-duty chaos, and it starts now. Have you ever wondered what happens behind the scenes of the wood industry? How raw timber is turned into smooth panels, powerful fuel, or high-grade furniture components? Welcome to this deep dive into the world of wood crushers and wood processing machines, where steel meets timber and innovation fuels productivity. In the next 20 minutes, we're going to explore the different types of wood crushers, how they work, their applications, and what makes each machine unique. But before we jump in, tell me, do you like this kind of intro? Do you want more content like this, explained with clarity, energy, and real-world relevance? Drop your thoughts in the comments or hit that like button. Your feedback fuels this content, just like diesel fuels a drum chipper. Now, let's get to the heart of wood processing. When you need to reduce wood into sawdust, and you're dealing with mixed, tough, unpredictable feedstock, there's only one machine you can trust: the twin-shaft wood crusher. Unlike high-speed chippers or hammer mills, this machine doesn't rely on impact or blade speed. It's all about torque, slow, powerful, and relentless. At its core, two counter-rotating shafts pull wood inward, crushing it between hardened intermeshing teeth. Tree trunks, roots, pallets with nails, bark, bamboo, construction debris, this machine doesn't flinch. The design minimizes clogging, handles inconsistent material sizes, and keeps working even when the feed changes mid-batch. Each shaft is powered by a heavy-duty gearbox. Hydraulic couplings absorb shock, and the steel frame, it's overbuilt on purpose, because this machine is designed for 24/7 industrial duty. You can add a screen to control output size, or connect the crusher to a hammer mill for finer powder, or mount it on a conveyor system for continuous production. From biomass energy plants to composting stations to wood recycling centers, the twin-shaft system is trusted for one reason: reliability. But let's talk about safety. These aren't blades, they're mechanical jaws, capable of chewing through steel bolts if needed. Never reach into the hopper. Always use hydraulic pushers or controlled feed conveyors. The noise level is lower than high-speed shredders, but the force is unmatched. And so is the danger. Emergency shutoffs, interlocked access panels, overload sensors, and these are not optional. Smart facilities automate feed control, temperature monitoring, and output sampling, ensuring quality and machine health in real time. And here's what really sets this machine apart: it doesn't need perfect wood. It thrives on difficult, dirty, inconsistent input, the kind of material other machines jam on. If you're processing massive volumes of material and can't afford downtime, this is your workhorse. Low maintenance, high output, unstoppable torque. This isn't just a shredder, it's an industrial solution. This is the twin-shaft wood crusher. crisp morning at the log yard, large tree trunks lie in rows waiting to be processed. In the middle of this scene stands a distinctive glue machine, an industrial wood grinder designed to turn raw timber into fine sawdust for multiple industries. This drum-type wood grinder consists of a sturdy engine base, a knife drum fitted with sharp serrated blades, an in-feed system with upper and lower conveyors to push wood into the machine, a discharge conveyor to carry sawdust out, hydraulic buffers to reduce vibration, and an electrical control system to monitor operating parameters. Such a structure allows it to handle not only logs but also branches, wood waste, and even some non-wood materials. Before starting, the operator, fully equipped with protective gear, checks the blades, the tension of the conveyor, and ensures there are no foreign objects in the infeed chamber. Safety sensors and emergency stop buttons are verified to guarantee maximum security. Once the machine runs, a crane places logs onto the feed belt. The wood is pulled into the drum, where high-speed blades slice it into chips and then grind those chips into sawdust. The process is continuous. Wood goes in at one end, sawdust comes out on a conveyor at the other. Each hour, the machine can grind dozens of cubic meters of wood, producing large quantities of sawdust for making particle or fuel pellets or organic fertilizer. Collected sawdust is loaded onto trucks and transported to factories. From these tiny particles, people produce biofuel pellets, composite boards, or use it as a substrate for mushroom cultivation. Thus, timber is utilized to the fullest, reducing waste. After a shift, the machine is shut down for maintenance. Mechanics remove the cover, sharpen the blades, lubricate components, and clean out any remaining sawdust. Regular maintenance keeps the grinder running smoothly and prolongs its service life. As the sun sets, the grinding plant falls silent. The smell of wood and sawdust lingers in the air, signaling a productive day has come to an end. The wood grinder is not only a symbol of mechanical power, but also evidence of ingenuity in maximizing forest resources. This technology plays an important role in the sustainable and efficient production chain of the forestry and wood processing industry. After safety checks, tension of the belts, condition of the knives and control systems, he starts the machine and the conveyor begins to move. The first log is placed on the belt. Feed rollers grip it tightly and draw it into the drum. Inside, a drum fitted with dozens of serrated blades spins at high speed. When the wood makes contact, the knives shave it into small chips. These chips are further crushed as they strike the housing and secondary blades, quickly becoming fine sawdust. The particles are carried on an air stream and drop onto the discharge conveyor. Throughout the process, the operator watches parameters on the control panel. Rotation speed, engine temperature and power consumption. If a log is too hard or too large, an overload sensor triggers and the conveyor stops to prevent damage to the knives. As the sawdust is discharged, a dust extraction system collects fine particles into filter bags, keeping the surrounding air clean. Finished sawdust is gathered into bins. It will be used as feedstock for particle board, biofuel pellets, or as mulch in agriculture. Converting waste wood into high-value products is the main goal of this line. At the end of the shift, the worker shuts down the machine, allows it to cool, then performs maintenance, removing and cleaning the knives, inspecting the conveyor, lubricating bearings, and cleaning the dust filters. He assesses the amount of sawdust produced and plans the next day's feedstock. Even though the wood grinder is not massive, the efficiency it provides is significant, saving time and labor while turning otherwise discarded wood into useful sawdust. In a modern wood processing facility, long tree trunks are stacked neatly beside a set of interconnected machines forming a single production line. At the heart of the system is the wood grinder, but its effectiveness depends on the surrounding automation. Together, these components transform raw timber into fine sawdust quickly, continuously, and safely. Logs are placed onto the in-feed conveyor, where rubber and steel rollers grip them and carry them toward the machine's mouth. Upper and lower feed mechanisms hold the logs steady to prevent them from bouncing or slipping. As they reach the drum-type grinder, the knives on the rotating drum go to work, spinning at high speed and slicing the wood into small chips. These chips continue to be pulverized as they collide with the drum housing and secondary blades, turning into fine sawdust. A discharge conveyor at the end of the grinder moves the sawdust onward, preventing clogs. The sawdust then passes through a screening system that removes any oversized pieces. Chunks that are too large are returned to the grinder for another pass, while sawdust that meets the specification travels through an enclosed conveyor to a collection area. There, a dust extraction system separates the sawdust from the airflow, minimizing airborne dust and keeping the workshop clean. An operator monitors the entire line from a central control panel, watching belt speeds, grinding power, and engine temperature. Sensors issue warnings if the machine is overloaded or if a foreign object becomes trapped, allowing the line to stop instantly for troubleshooting. The whole process, from feeding logs to collecting sawdust, is nearly closed loop and requires only a few staff members to supervise. Sawdust has many uses. It is feedstock for particle board, MDF, and OSB. It can be pressed into clean fuel pellets, or it serves as a substrate for mushroom cultivation. Producing sawdust on a conveyor line helps maximize the use of timber and waste material, reducing labor costs and processing time compared with manual methods. At the end of a shift, the line is shut down for maintenance. Workers clean the conveyors, inspect and sharpen the knives, lubricate bearings, and replace dust filters. With regular maintenance, the system is always ready for steady operation in the next production run. The conveyor-based wood grinding line not only boosts manufacturing efficiency, but also contributes to a sustainable value chain in the wood processing industry. A log is placed on the loading table and the conveyor starts pulling it toward a fixed chainsaw. The saw drops and cuts the log into shorter lengths in an instant. As soon as the cut is complete, the conveyor pushes the section into the splitting chamber. A powerful hydraulic piston forces the wood through a cross-shaped wedge, cleaving it into equal pieces. The split pieces fall onto a second conveyor and are carried to a collection area. Throughout the process, the operator stands at the control panel monitoring the feed speed and hydraulic pressure, ready to make adjustments if needed. An automatic lubrication system sprays oil onto the chainsaw and splitting blades to keep the machine running smoothly. When the batch of firewood is finished, the machine is stopped for inspection and cleaning before the next run. A log is placed on the loading table at the head of the conveyor. When the machine starts, a rubber belt pulls the piece toward the cutting station. A fixed chainsaw mounted above the belt swings down, slicing the log into shorter sections. As soon as the cut is complete, the conveyor carries the piece into the splitting chamber. Here, a hydraulic piston pushes the wood against a cross-shaped blade. With a single thrust, the log is split into 4 or 6 pieces, depending on the wedge configuration. The newly split pieces drop onto a second conveyor and move to the collection area. Thanks to the continuous conveyor system, workers don't need to lift each log. All heavy handling is automated. The operator stands at a control panel, watching the belt speed, the cut length, and the hydraulic pressure. When adjustments are needed, he simply turns a dial or presses a button to change the cutting length or the number of splitting blades. Throughout the process, lubricating oil is automatically sprayed onto the chainsaw and splitter blades to reduce wear. Steel and clear plastic guards shield the operator from flying wood chips. Warning lights flash whenever the machine encounters an overload, signaling that the infeed rate should be reduced. When the batch is finished, the machine is shut down for inspection. The chain tension is reset, the splitting blades are sharpened, and sawdust is cleaned from the belts. By combining a chainsaw, splitter, and conveyors, this system makes firewood production much faster, safer, and less labor-intensive than manual methods. Winter approaches at a small rural woodshop, a worker gets ready to operate a hydraulic wood splitter. Unlike chainsaws or rotary blades, this machine uses the raw force of a hydraulic piston to push logs through a splitting wedge. The machine is mounted on a sturdy steel frame. On one end, there's a flat backstop where the log is placed upright. In the middle sits a sharp wedge in a V or cross shape, and on the other end is a hydraulic piston powered by a pump and cylinder. When the switch is turned on, the engine activates the hydraulic system, building pressure and preparing the piston to move. The operator lifts a log and places it against the wedge. With a pull of the control lever, the piston slowly pushes the log forward. As it meets the wedge, the wood begins to split along its grain. A sharp, cracking sound echoes as the log is cleanly divided into 2, 4, or even 6 pieces, depending on the wedge shape. The split firewood falls to the sides or onto a conveyor for collection. The process is repeated quickly, the piston retracts, a new log is loaded, and the cycle continues. Thanks to the machine's strong force and smooth motion, each log takes just a few seconds to split. It can handle even the toughest hardwood without effort from the user. Built-in safety valves release excess pressure if an obstruction is encountered, preventing damage to the piston or blade. While operating, the worker wears gloves and safety boots, keeping hands away from the cutting zone. The machine is equipped with a protective shield to prevent flying debris, and emergency stop buttons are located near the controls in case of trouble. At the end of the shift, the machine is powered down and cleaned. The operator brushes away wood chips, inspects the wedge, cylinder, and hoses for wear or leaks, and refills the hydraulic oil if needed. All bolts are rechecked for tightness. With regular maintenance, the piston wood splitter runs smoothly throughout the cold season, ensuring a steady supply of firewood for heating and cooking in nearby homes. A sharp pull on the cord, and the chainsaw roars to life. The two-stroke engine growls as the chain whips around the guide bar at high speed. The operator quickly checks the chain brake and guards, then steps up to the tree. Planting his feet firmly, he grips the front handle and rear throttle handle, leaning in to position the bar about 45 degrees to the trunk. The chain touches the wood, creating a shallow notch to mark the cut. He makes a bore cut by gently pushing the bar tip into the trunk, then rotates the saw to deepen the cut. Once the opening is large enough, he switches to a horizontal cut to finish the face notch, pausing occasionally to clear accumulated sawdust. The tree begins to sway, and as the main cut nears completion, he moves to the opposite side for the back cut, controlling the direction of the fall. The heavy trunk crashes down exactly where intended, the impact echoing through the forest. Next, the chainsaw is used to buck the fallen tree into shorter sections. He places the bar on the log, applying light, steady pressure so the chain can feed itself through the wood. Each cut is clean and decisive. He constantly watches the curve and adjusts the throttle to prevent binding. When ripping along the grain to produce planks, he attaches a temporary guide to the bar to keep the cut straight and runs the saw down the full length of the log. Throughout the work, he regularly checks and oils the chain to reduce friction and monitors the engine temperature. When the saw seems to lose power, he stops to adjust chain tension and clean the air filter. Safety is paramount. He maintains a safe distance from others and wears a face shield, protective goggles, and cut-resistant gloves. Each time he changes position, he turns off the engine and engages the chain brake to avoid unexpected contact. segment, after all cuts are made, he shuts down the saw, lets the engine cool and performs maintenance, clearing sawdust from the housing, inspecting and sharpening the chain and refilling fuel and bar oil for the next use. He stacks the cut sections neatly, surveys the completed work and concludes the session. The story closes with the chainsaw placed back in its case, ready to unleash its power another day. The chainsaw, compact, powerful, essential, whether you're felling trees, bucking logs, or clearing storm debris. The chainsaw is a core tool in forestry, arboriculture, construction, and emergency response. But make no mistake, this is not a casual machine. It's one of the most dangerous tools in the industry. Let's break it down. A chainsaw consists of a two-stroke gas or electric engine, a clutch, a drive sprocket, a guide bar, and a cutting chain. The chain moves at speeds up to 70 feet per second. Each tooth acting like a miniature chisel, ripping through wood with ease. That speed gives it power, but that power comes with risk. Kickback is the most dangerous hazard. When the upper quadrant of the bar tip contacts an object and throws the saw back toward the user in milliseconds, it can be fatal. Vibration fatigue is another threat. Hours of use without anti-vibration handles can lead to loss of grip, reduced control, and long-term nerve damage. Chain snap, bar pinch, over-revving, fuel leaks, all real dangers, all preventable with training and awareness. Modern chainsaws are equipped with safety features: inertia-activated chain brakes, chain catchers, anti-vibration systems, throttle interlocks, handguards, low kickback chains. But even with all this, safety begins with the user. Before starting any saw, 1. Check fuel or battery level. 2. Inspect the chain tension. Too tight and it burns out the bar, too loose and it derails. 3. Ensure proper lubrication with bar oil. 4. Confirm the chain brake is engaged before pulling the cord or pressing the trigger. Wear your PPE. Chainsaw chaps, cut-resistant gloves, hearing protection, helmet with visor, steel toe boot. When cutting, maintain a wide stance. Keep both hands on the saw at all times. Never cut above shoulder height. Avoid cutting with the tip. That's where kickback lives. Always be aware of your surroundings, terrain, bystanders, and obstacles. Chainsaws aren't just for pros, but they demand professional respect. In the right hands, a chainsaw is a surgical tool, clearing limbs, shaping trees, sectioning logs cleanly and quickly. In untrained hands, it's chaos, damage to property, injury to self, or worse. Situational awareness is key. Use wedges when felling trees. Use a bucking stand when cutting firewood. Always plan your escape route before making the first cut. And remember, when a chainsaw fails, it's rarely the machine's fault. It's operator error, lack of focus, lack of respect. Even seasoned professionals make mistakes, but they train constantly to minimize risk. So before you pick up a chainsaw, ask yourself, are you trained? Are you focused? Are you prepared to treat every cut like it matters? Because it does. This tool is unforgiving. It doesn't pause. It doesn't hesitate. It only cuts. Fast, relentless, unstoppable. This is the chainsaw. At a logging site, a worker grips his chainsaw firmly and checks the chain tension, fuel level, and starter cord. With a few pulls, the engine roars to life, its powerful hum echoing through the trees. He lowers the saw, and the chain spins rapidly, producing a sharp mechanical whine. The bar meets the thick tree trunk, slicing cleanly through the bark and deep into the grain. Sawdust sprays in all directions as the sharp chain chews through the wood. The worker follows a precise cutting line, shifting his stance slightly to maintain balance and steady pressure. Within seconds, a large section of the trunk is severed. He turns off the engine and places the saw down, inspecting the cut, straight, smooth, and efficient. That's the power of a chainsaw. Compact, agile, and incredibly effective in the hands of a skilled operator. The sawmill powers up. A giant circular blade spins so fast it appears as a silvery blur. A long log is fed forward by a conveyor, while two clamps hold it firmly in place. In moments, the blade bites into the wood and cuts straight through, producing that distinctive whirring sound and a spray of sawdust. The operator adjusts the sliding table so the log moves smoothly across the blade. On the other side, thick wooden boards are separated one by one and neatly stacked. After each cut, an automatic system sprays water onto the blade to cool it, reducing friction and preventing the wood from burning at the edges. A screen displays key parameters such as cutting speed, board thickness, and blade temperature, allowing the operator to keep tight control. Next, the machine adjusts the cutting angle to rip the log lengthwise, producing boards of various widths. Guide rollers feed the sawn boards through an edge planer to smooth the surfaces. The entire process runs continuously. Logs go in at one end, finished lumber comes out at the other. Thanks to sensors and automated controls, productivity increases significantly without sacrificing precision. At the end of the segment, the machine halts for maintenance. The blade is removed for sharpening, moving parts are lubricated, and the sawdust is cleaned away. The operator checks all safety devices before preparing for the next shift. The story concludes here, emphasizing efficiency, accuracy, and the importance of proper maintenance in the wood processing industry. a shift. Every cut straight, every piece usable. No more guessing, no more slowdown. Just clean, accurate lumber, hour after hour. For flooring, framing, furniture, or fuel, this is where raw timber becomes refined material. This is the industrial wood saw. The workday begins with the roar of machinery in the sawmill. A technician powers up the systems, checks the cooling circuit and fills the lubrication reservoir. A massive circular steel saw blade spins up to speed, glinting under the lights. Feed conveyors stand ready to push long logs toward the cutting table. The first log is fed in. Two clamps hold it firmly as the blade contacts and cross-cuts the trunk into billets of predetermined length. Sawdust flies, but the dust extraction system immediately captures it, keeping the cutting area clean. The technician watches the control panel, adjusting cutting speed to suit the diameter and species of wood, while controlling the water spray that cools the blade to prevent overheating. Next comes the ripping stage. The freshly cut billets are moved to a ripping saw to be split into planks of varying thicknesses. The operator adjusts the fence on the saw table to set the board width. The blade height and angle are calibrated precisely. As the machine runs, the log advances slowly past the blade with a steady whir. Each board emerging from the saw is sorted into categories: main boards, secondary boards, or beams. Boards with defects such as knots or cracks are marked for separate processing. After ripping, the boards are sent to the planer to flatten and achieve uniform thickness. The technician sets the cutter head depth and feeds boards through the rollers. The surfaces come out smooth, ready for sanding. A worker uses a large belt sander to process long boards, while smaller or intricately patterned boards are smoothed with handheld orbital sanders. The sanding machines whine as layers of wood fiber are polished away and the surfaces become bright and clean. Safety is paramount throughout the operation. Every worker wears protective glasses, masks, and hearing protection. Emergency stop buttons are placed in multiple locations to shut down machines immediately if something goes wrong. Sensors monitor vibration and detect blade misalignment. When an alarm sounds, the saw automatically slows and stops for inspection. As the shift draws to an end, the saw is shut down for maintenance. The technician removes the blade from the arbor, checks its wear, and sharpens it with a specialized grinder. The shaft and bearings are cleaned and lubricated. Conveyors and rollers are brushed free of sawdust and sprayed with anti-corrosion oil. At the same time, the operation log records the volume of wood sawn, species, board thicknesses, and operating time. Finally, the sawmill falls quiet again. Straight, smooth boards are stacked neatly, ready for transport. The saw has done its job, transforming rough logs into high-value semi-finished products that await the next stages of processing. The industrial wood saw is not just a machine, it's the heartbeat of every lumber operation. Whether you're breaking down logs or processing slabs, this saw is engineered for consistency, speed, and surgical accuracy. It starts with a heavy-duty steel frame, vibration dampened and rock solid. The blade, whether circular, band or gang, spins at precisely calibrated speeds, able to slice through hardwood, softwood, or composite material with ease. Logs are automatically fed into the system, aligned by sensors and rollers. Each cut is optimized by software to reduce waste and maximize yield. Precision isn't optional, it's built in. Millimeter adjustments, blade angle control, variable feed rates. This is high-performance sawing made automatic. And with safety features like blade guards, laser alignment, and emergency stops, operators stay protected while maintaining full production flow. The result, thousands of board feet per. Have you ever wondered what happens behind the scenes of the wood industry, how raw timber is turned into smooth panels, powerful fuel, or high-grade furniture components? Welcome to this deep dive into the world of wood crushers and wood processing machines, where steel meets timber and innovation fuels productivity. In the next 20 minutes, we're going to explore the different types of wood crushers, how they work, their applications, and what makes each machine unique. But before we jump in, tell me, do you like this kind of intro? Do you want more content like this, explained with clarity, energy, and real-world relevance? Drop your thoughts in the comments or hit that like button. Your feedback fuels this content, just like diesel fuels a drum chipper. Now, let's get to the heart of wood processing.
Engineered for stability, boasting an impressive lifting capability and a turning moment of 59 kN/meter.
Right before our eyes, the arm of the excavator swings out and clamps around a tree trunk. The specialized cutting head grips tight, the saw blade spins, and the tree is severed from its base in seconds. Without relocating, the feed rollers immediately drag the trunk through a set of stripping knives. Steel rollers squeeze and rotate to peel away the thick bark. Strips of bark fall to the ground, leaving a smooth log ready for the next stage. The machine repeats this cycle: grip, cut, debark, set down, each taking less than a minute. By combining felling and debarking in one device, it dramatically shortens processing time and reduces the workforce needed. In modern logging operations, this solution boosts productivity while keeping workers safe, as all heavy tasks are controlled by a single operator. At the end of the segment, the debarked logs lie neatly in a row, ready for transport. The operator shuts down the engine, checks the cutting head, and ends the shift. The story closes there, underscoring the efficiency and convenience this technology brings to forestry. When it's time to clear thick brush, saplings, and overgrowth, The rotary drum mulcher on a wheel loader gets it done. This setup delivers unmatched control and torque. The rotating drum chews through dense vegetation smoothly, with less flying debris and a cleaner mulch finish than disc systems. The loader's articulation helps maneuver around trees, ditches, and fence lines. And with hydraulic float control, the drum glides over terrain with precision. Ideal for roadside clearing, utility paths, and forestry maintenance. This combo handles 4 to 6 inches of growth without slowing down. Operators can tilt, angle, and fine-tune cuts on the fly, making every pass count. It's not just about cutting fast, it's about cutting smart. This is the wheel loader with rotary drum mulcher. When the job calls for fast, aggressive clearing, you bring in the disc mulcher. Mounted on a wheel loader, this setup combines brute force with mobility. The spinning disc reaches full RPM in seconds, slicing through brush, vines, and trees up to 8 inches thick. Unlike drum mulchers, disc systems use speed and impact, launching debris, pulverizing trunks, and flattening terrain in one pass. It's not for finesse, it's for maximum ground coverage, fast turnaround, and tough vegetation. The wheel loader provides stability on uneven terrain, and articulation makes it easy to maneuver around structures, poles, or steep inclines. Operators can angle the head, engage from the side, or drop straight into dense clusters, but make no mistake, this machine demands respect. The force, the speed, the debris, it's all intense. That's why you suit up. Heavy-duty glass, guards, and distance protocols for clearing storm-damaged fire lines, overgrown fields, and reclaimed land. The disc mulcher on a wheel loader is the go-to. It's fast, it's fierce, it's built for battle. This is disc-based brush obliteration. Across a field overgrown with tall grass and dense brush, a wheel loader rumbles forward. Mounted on the front is a fast-spinning rotary or drum-type clearing head, its blades sharp and relentless. As it moves, thick vegetation is shredded instantly, leaving a clean path behind. Dust clouds rise, but the operator stays protected inside the sealed cab. In just a few seconds, a large patch of land is cleared with precision. Powerful, efficient, and built for tough jobs. That's the force of this all-terrain clearing machine. The wheel loader moves into position, the long auger bit mounted on its front spinning rapidly. The operator lowers the hydraulic arm, placing the bit at the center of the stump left after felling. The helical blade bores into the ground, grinding the roots and stump into fragments. Once it reaches the desired depth, the machine lifts the auger, pulling loose wood chips and soil upward. Then the loader uses its bucket to scoop up the shattered stump pieces and surrounding dirt, clearing the area for new planting or construction. The wheel loader slowly approaches the large stump left in the ground. Instead of the usual bucket, a large disc with serrated cutting teeth around its rim is mounted on the front arm. The operator engages the grinding unit and the disc begins spinning at high speed, emitting a distinctive hum. He lowers the disc onto the stump, and each rotation of the cutting teeth abrades the wood. The serrated edges bite in and shred the stump into sawdust. The operator sweeps the disc from side to side to grind the entire surface evenly. After a few minutes, the above-ground stump has been transformed into a shallow pit filled with wood chips and broken roots. Next, the machine raises the grinding disc and switches to the bucket attachment to scoop up the sawdust and debris. By combining both functions on a single platform, the work becomes continuous grind, collect, load. The operator can adjust the disc's rotational speed to match the hardness of the wood while monitoring engine temperature and tooth wear. At the end of the session, he shuts down the machine and performs maintenance. The teeth on the disc are replaced or sharpened as needed. The spindle is lubricated and the wheel loader's hydraulic system is checked for leaks. This combination makes stump removal quick and efficient compared with manual methods, clearing the ground for replanting or construction. At a busy quarry site, the thunderous sound of metal on stone fills the air. A massive rock crusher is in full operation. Large boulders are loaded into the hopper, slide down the vibrating feeder, and enter the crushing chamber. Inside, powerful jaws or rotating hammers apply intense pressure. As the stones are gripped, they crack, collide, and grind against one another. With every rotation, the rocks are broken down into smaller fragments, gradually reduced to sharp-edged gravel. The entire process is closely monitored through a control panel. Crushing speed, vibration, motor temperature, and power levels are all tracked in real time. A conveyor belt carries the crushed material out of the machine. There, a vibrating screen sorts the gravel by size. Coarse gravel for road foundations, medium-sized aggregate for concrete.
Đinh chỗ nào đây? Qua nơi đâu?
Em đinh mà
cắt sát hẹp đinh luôn.
Viết
chúc để cái chim.
Tôi có tiền này ạ.
Nghề tôi chứ là nghề của em. Đánh ngựa đó à? Bây giờ cái trứng này mình hết không đó.
Bỏ luôn hết, nhanh hết luôn.
Dáng xin chào nữa. Cái bữa thì xin nữa mà.
Hello hả?
Hello, xin chào chào.
Chào chào.
Biết chào anh. Quay gì quay được. Quay hết chưa?
Quay nguyên cái chạo vô đó vậy.
Một, hai, hết.
Đưa anh Thớ nó làm cài KPI không không? Đâu KPI mà anh Thớ xuất hiện nhiều nhất mà. Em kết được cò quay hết á.
Tiền mua được.
Xong rồi. Có cái kia cái màn này trong dưới. Nó xử lý luôn cái tí cái đường.
Cái chỗ này nó để dài là nó bỏ ít thôi, bỏ ít thôi. Bỏ ít rồi đó. Bỏ đi trước.
Cái đầu thang đầu quận là vừa rẽ. Nếu mà cái đo màu nhói nhói được. Quay gì cũng biết. Đấy.